Here's a geometry problem that might also give you some practice with algebra. Pause the video and give it a try. Okay, here's one way to solve the problem. We're trying to find the radius of this circle, and the circle has a triangle inscribed in it. Now, when you have angles inscribed in circles, a useful theorem is the inscribed angle theorem. For example, if we pick this angle alpha, then we know that the arc opposing it is 2 alpha in degrees, which is the same thing as saying that this angle here is twice the angle alpha. And that's useful because this triangle here is an isosceles triangle, and both sides of it have length r, since it's a circle of radius r. So we have two triangles now that share the side length 15, and we know the angles being opposed, alpha and 2 alpha. So what we're going to want to use is the law of cosines. So we're going to use it twice, both for 15 here. So this side length 15 can be made into a triangle using this big one or using this smaller one. And we're going to do them both. So first the big one. The big one, the law of cosines says the opposing side squared is equal to the sum of the squares of the two sides. And if it were a right triangle, that would be it. But since it's not a right triangle, we need to subtract off 2 times the side lengths times cosine of alpha. That's for the bigger triangle. Now for the smaller one, which has 2 alpha involved, we again have 15 squared. But now the opposing sides are these ones, just the radius of the circle, each one. And so it's just r squared plus r squared minus 2r squared cosine, and now 2 alpha. And so we have two equations for two unknowns, alpha and r. And it looks to me like the easiest way to get r, which is what we're asked for, is going to be first to solve the top one to get alpha. So from this one, we have 15 squared minus 10 squared minus 12 squared divided by minus 2 times 10 times 12 is equal to cosine alpha. So alpha is just the arc cosine of this stuff in here, and if you work it out and plug it into your calculator, it comes out to about 1.5 radians. So that's alpha. And then from the bottom equation, now that we know alpha, we can just solve it for r. So from this equation, I see that the left-hand side becomes 2r squared times 1 minus cosine 2 alpha, but alpha we know is 1.5. And that's all equal to 15 squared. And so finally we can solve for r squared is 15 squared over 2 times 1 minus cosine of approximately 3 radians, or r is 15 over the square root of 2, 1 minus cosine 3. And that's 3 radians, and when you plug that into your calculator, you'll find it's approximately 7.5.